Hello, in this video, we'll learn how to form a quadratic equation with given roots. And we have three problems we are going to solve. Without wasting time, let's begin. Question number 1. Form the quadratic equation whose roots are 5 and 1. When solving a quadratic equation, we are required to find the roots of the equation. The equation is known, but the roots are unknown. But in this case, the roots are known, but the equation is unknown. So we are required to form or create the equation with the given roots. We are going to introduce a formula for solving problems like this. The formula is x squared minus sum of roots with x plus product of roots equal to 0. Now we are going to take note of this sum of roots and product of roots. They are very vital. So to solve this problem, we'll take note of the roots. The roots are 5 and 1. So the first thing we'll do is to get our sum. That is sum of roots. Now, sum of root means that we are adding the roots. So this becomes 5 plus 1, and that will give us 6. Now, product of roots means that we are multiplying the product. We are multiplying the roots. So we have 5 multiplied by 1, and that will give us 5. So now we have our sum and we have our product. We are going to substitute into this formula, and we'll have x squared minus, in place of sum of roots, we are going to put 6. Close our bracket and put x plus product of roots. We'll have 5. So put 5. Everything is equal to 0. So if we open up, we'll have x squared minus 6x plus 5 equal to 0. This is our answer. So this is the equation whose roots are 5 and 1. So we are going to verify this by solving this quadratic equation using the factorization method. The coefficient of s squared is 1 here, so 5 here becomes our product and minus 6 becomes our sum. So we'll look for two numbers that will multiply to give us plus 5. And if we sum them, the result should be minus 6. So those numbers are minus 5 and minus 1. Minus 5 times minus 1 is plus 5. And if we sum them, the result is minus 6. So we'll bring them in. S squared minus, in place of minus 6x, we'll put minus 5x and minus x plus 5 is equal to 0. We'll factorize by grouping. So here x is common. We have x minus 5, and here is minus 1 into x minus 5. We have our two brackets are the same, so we'll pick one. I'll create the second bracket, x minus 1 equal to 0. So x minus 5 is equal to 0, or x minus 1 is equal to 0. So if we move minus 5 to the right hand side here, we'll have that x is equal to 5. And here, if we move minus 1 to the right hand side, we'll have that x is equal to 1. So we are on the right track. So we are going to look at the second question. The second question, form the quadratic equation whose roots are minus 3 over 4 and 4 over 3. Now using the same formula, now we'll find the sum. Our sum will be equal to minus 3 over 4 plus 4 over 3. So if we add this up using the cross multiplication method, so how that 3 times minus 3 is equal to minus 9, and 4 times 4 is 16, all over the denominator, product of the denominators. So 4 times 3 is 12. And this gives us 16 minus 9 is 7 over 12. So this is our sum. So we'll go for the product. The product will have minus 3 over 4 multiplied by 4 over 3. Now, okay, let's just multiply. Minus 3 times 4 is minus 12. And 4 times 3 is 12. So 12 will cancel 12 and we'll have minus 1. So our sum is 7 over 12 and our product is minus 1. So the next thing is to substitute into the formula. So we have s squared minus sum of roots. Our sum of roots is 7 over 12 x plus the product of roots, which is minus 1. And everything is equal to 0. So we'll have, if we open up, we'll have s squared minus 7 over 12x plus minus is minus. So that gives us minus 1 is equal to 0. So in our equation, we have a fraction here. And we'll need this place to be a whole number. So that means that we'll eliminate this 12. For us to achieve that, we'll multiply all through by 12. If we do that, here becomes 12 s squared minus 12 7 over 12x minus 12 equal to 0. So now this is 12s squared minus 12 will cancel out with this 12 and we'll have just x, 7x minus 12 times 1 is 12 is equal to 0. So this becomes the equation with the given roots. Now, as we did in the first question, we can also verify if our answer is correct. So we are going to solve this equation using the factorization method. So here now the coefficient of s squared is 12. So what we'll do is to multiply 12 by this 12 here. That will give us 144. So we'll look for two numbers that will multiply to give us minus 144 because of this negative sign. And if we sum them up, the result will be minus 7. What are these numbers? So without wasting time, we have that the numbers are 9 and minus 16. So we'll have 12s squared plus 9x minus 16x minus 12 is equal to 0. So we are using 9x and 16x to replace minus 7x. So if we factorize by grouping, between 12 and 9, 3 is common. So we have 3x common. And if we divide, here we'll have 4x plus 9x divided by 3x is 3. Minus 16 and 12, we have 4 is common. So here is 4x plus 3 equal to 0. Two brackets are the same. We'll take 1. Create the second. 3x minus 4 is equal to 0. So that means that 4x plus 3 is equal to 0, or 3x minus 4 is equal to 0. 4x, if we move 3 to the right hand side, it becomes negative, or 3x will move minus 4 to right hand side, it becomes 4. So if we divide both sides by 4 here, we'll have that x is equal to minus 3 over 4, or if we divide both sides by 3 here, and we'll have that x is equal to 4 over 3. So x is equal to minus 3 over 4 or 4 over 3, which corresponds to the root given. So we are on the right track. So we'll look at the last question for today. Our last question for today: form the quadratic equation whose roots are 1 minus root 13 and 1 plus root 13. So go ahead and find our sum. So that will be 1 minus root 13 plus 1 plus root 13. So minus root 13 plus root 13 is equal to 0. So that will cancel out. And we have 1 plus 1 equal to 2. So our sum is equal to 2. Our product, we have 1 minus root 13 multiplied by 1 plus root 13. So if we expand this, we'll have 1 times 1 is 1 squared. 1 times root 13 plus root 13 minus root 13 times 1 is minus root 13. And minus root 13 times plus root 13 will be minus root 13 squared. So 1 squared is 1. Root 13 minus root 13 is 0, so that will be off. Minus, here, the square here will cancel out with the square root, and we have 13 left. So this is 1 minus 13. And 1 minus 13 is minus 12. So our product is equal to minus 12, while our sum is 2. If we substitute with the formula, we'll have s squared minus sum of roots is equal to 2x plus product of root is minus 12, and everything is equal to 0. So if we go further, we'll have s squared minus 2x plus minus is minus, and we'll have minus 12 is equal to 0. So this becomes the equation whose roots are 1 minus root 13 and 1 plus root 13. So as we did for question number 1 and 2, we are going to verify this by solving this equation, and we'll see if we are going to get these roots, 1 minus root 13 and 1 plus root 13. We cannot factorize this equation, s squared minus 2x minus 12. Hence, the factorization method will not work. So we are going to use the quadratic formula. So here we have that a is 1, our b is minus 2, and our c is minus 12. We are going to substitute into the formula. So we'll have x is equal to minus b, our b is minus 2, plus minus square root of minus 2 squared minus 4a, which is 1, and c is minus 12. Everything over 2 times 1. And we'll have minus minus is 2, so we'll have 2 plus or minus the square root of minus 2 squared is 4. Then minus 4 times 1 is minus 4. And minus 4 times minus 12 is plus 48. All over 2. And that will give us 2 plus minus square root of 4 plus 48 is 52 over 2. So this will give us 2 plus minus 52 is not a perfect square, so we're going to simplify it. So 52 is going to be the same thing as 4 times 13 divided by 2, and that will give us 2 plus minus. Now 4 is a perfect square, so we'll get the square root of 4, which is 2, bring it out of the square root, and 13 will remain in the square root. So we'll have 2 root 13 over 2. So now, the next thing is to factorize. We're going to factorize this. So this is the same thing as 2. Here will be 1 plus minus root 13. We factorize the numerator because 2 is common. So we'll divide everything by 2. So here now 2 will cancel out with this 2. And we have that x is equal to 1 plus minus root 13. Alright, so we have two cases here, plus and minus. So the first case, if we use plus, we have that x is equal to 1 plus root 13. And if we use the second case, we'll have that x is equal to 1 minus root 13. So we have that x is equal to 1 plus root 13 or 1 minus root 13, which corresponds to the root given.